finding the inverse of a linear function has a couple of steps that we need to follow. But not only do we have to find the function, we also have to use composition in order to check our work, okay? So the steps to find the inverse of a function, first of all, we're going to substitute y for f of x. We're going to switch x and y, since the inverse switches the outputs and the inputs. We're going to solve for y, and then we're going to replace y back to function notation. And this here, f to the power of -1 of x, indicates that we are working with the inverse function, where f of x is the original function, okay? Once we have found the inverse of a function, we are going to use composition to check that they are inverse. Now, if they are inverses, the following will be true. We will show that f, or the function, of the inverse function of x is equal to x, and that the inverse function of f of x is also equal to x. Okay, so let's find the inverse for the given function and then use composition to verify that the functions are inverses. Then make a table of values to graph the function and its inverse. So you can see our function here, f of x equals 3x plus 4. First thing we're going to do is replace f of x with y. So all I did was rewrite the function, and instead of using function notation, which is f of x, I rewrote it using a y value. The second step is to now flip x and y. So x and y have flipped places, meaning our equation is now x equals 3y plus 4. And because they have switched sides, we are now going to solve for y once again. So in order to solve for y, I'm going to subtract 4, and we have x minus 4 equal to 3y. And finally, we are going to divide by 3. Okay, so this is telling me that y equals x divided by 3 minus 4 divided by 3. And I do want you guys to get into the habit of splitting it, right? This is equivalent to this, but we want to make sure that we are simplifying as much as possible. We are dividing the x value. We are also dividing the constant value, and that is how we achieve a split number here. 1/3 x minus 4/3. Okay, remember x does have a coefficient of 1 in front of it. So we're going to take this one step further. We're now going to get rid of y. Because it is the inverse function, we are going to rewrite it using function notation. So our final solution will say the inverse function of x is equal to 1/3 x minus 4/3. Okay, this is the inverse function here. Now, composition is we have to prove it, okay? And the way we prove it is we are going to substitute the function into the inverse function, the inverse function into the function of x, okay? What that means is I am going to take this value here from the inverse and plug it in for x in the original function. So, original function says 3x, so I'm plugging in the inverse, plus 4, right? This equation is the original function with the inverse function substituted in for x. And we are going to simplify. So how do we simplify? We take this outside value and distribute it into the parentheses. 3 times 1/3 is simply 1x. 3 times -4/3 is -4. And then we have plus 4. Okay. Simplify here. -4 plus 4 is 0. So we are left with x, which means that the function of the inverse function of x is equal to x. And that is exactly what we wanted to show to prove the inverse. Okay, that's just one step. Then we are going to do the same for the inverse function of the function of x. Okay, which means that this time we are going to use the inverse function and plug in the original function in for x. Okay, so let's go ahead and do this. This time we have 1/3 x. So remember, we're plugging in the original function, 3x plus 4 minus 4/3. Okay. Simplify. Start by distributing the outside value into the parentheses. And we know that 1/3 times 3 is 1x. 1/3 times 4 is positive 4/3. And then we bring down that negative 4/3 at the end. Simplify. 4/3 minus 4/3 is 0, so we are left with x. So this time we are showing that the inverse function of f of x is equal to x. Okay, this is composition, so we know that our functions are inverses. And yes, you do have to check both of them. You have to check the function of the inverse function and the inverse function of the function of x. Okay. The next step was to make a table of values to graph the function and its inverse. And I know our function, if you look at the table, the graph, it is already graphed. Okay, that's fine. But how do we make a function? We need to create a table of values. We're just going to pretend that it's not already graphed, right? And we have to come up with our own table of values. So I'm going to make a table, f of x and x, right? And we're going to pick a couple of values. So I'm going to go with -3, -1, 0, and 2. Okay, these x values, we are going to take them and plug them into our original function. Okay, 3x plus 4. So when we substitute -3 in for x, 3 times -3 is -9, plus 4 is -5. So our value, our f of x when x is -3 is -5. Then we repeat, plug in -1. 3 times -1 is -3, plus 4 is +1. 0, 3 times 0 is 0, 0 plus 4 is 4, and 2. 2 times 3 is 6, plus 4 is 10. Okay, let's see what we can graph here. So if you look, -3, -5, here's that point, -1, 1, 0, 4, and then 2, 10 would be off of our chart. It would be somewhere up here. And for the inverse, we can do the same. Make a table of values, x, and now we're using the inverse of x, right? And you can plug in the same values. Or, if you remember, we already proved that there are inverses, so we can simply take our f of x values and our x values and flip them, because remember, inverses switch the inputs and the outputs. So if we do that, that means that my f of x values are now my x values, -5, 1, 4, and 10. And my x values are now my inverse function of x values, so -3, -1, 0, and 2. And you can always go back and double check. If you plug in, let's say 1, 1/3 times 1 is 1/3, and 1/3 minus 4/3 is -3/3, which is equal to -1. Okay, plot these points, and we would have a point at -5, -3, 1, -1, 4, 0, and then of course 2, 10, 2 would be off of our chart somewhere up here. And you can see this is how we would graph our lines. We would have our points, connect our points, and that would make up your function. Okay, let's go ahead and try one more. For b, we have f of x equals 2x minus 2. Remember, we start off by switching f of x into y. And then we switch our x and y values. They simply switch places. Everything else stays the same. And now we continue by solving for y. So in order to solve for y, I'm going to add 2 to both sides. I have x plus 2 on the left equal to 2y. Divide by 2 on both sides. And I have y equals x over 2 plus 2 over 2, which is 1. Okay. Finish by rewriting in function notation. So y becomes f to the negative 1 of x, which is the inverse function of x, equals 1/2 x plus 1. This is the inverse function here. Okay. Now, you have to show your composition to prove that the function of the inverse function of x equals x. This is what we're trying to prove. So we begin by writing our function, our original function, 2x minus 2. So I have 2x, which remember, now becomes the inverse function, so 1/2 x plus 1 minus 2. Okay, remember, all I did was take the inverse function and substitute that in for x. Simplify. 2 times 1/2 of x is 1x. 2 times positive 1 is 2, and minus 2 at the end. X plus 2 minus 2 simplifies down to x. And we have now proven this composition works. Second composition, we are now substituting the inverse function of the function of x, and we are proving that it equals x. Start by writing my equation, 1/2 x, and remember x is now the function, so 2x minus 2 plus 1. Okay, I took my original function and plugged it in for x in the inverse, and now we simplify. 1/2 times 2x is 1x. 1/2 times negative 2 is negative 1. Plus 1 simplifies down to x. So again, we have proven that it works. Now we are going to create our table of values. And for your table of values, really, you can pick any points that you want to use for x. My suggestion is let's keep them about the same just to make it easier on ourselves. Because we are multiplying by 2, let's use some small values here. Let's go with -4, -2, 0, 2, and 4. Okay, let's walk through this. You're going to substitute -4. 2 times -4 is -8. Minus 2 is -10. -2 times 2 is -4. Minus 2 is -6. 0 times 2 is 0. Minus 2 is -2. Positive 2 times 2 is 4. Minus 2 is +2. And 4 times 2 is 8. Minus 2 is 6. Okay, let's go ahead and plot those points. So we have -4, -10. That's off our chart. We can't graph that. -2, -6. Again, off of our chart. We can't exactly graph that. 0, -2. 2, +2. And 4, +6. So if we estimate, that would be about here. Same thing for the -6. I'm going to go ahead and estimate and say it's somewhere down here. We connect our line, and remember, try to draw as straight a line as you can. If you have a straight edge, like your ID or a piece of paper would work, right? Just line it up with a dot and connect them. I drew my line here. Connect your points. And there's your function, right? I'm trying to draw it as straight as I can here. All right, Then we're going to take our points and we're going to flip them. So I'm going to have x and the inverse of x. Okay, and again, remember this is function notation. It's the same as writing x and y to find our coordinate points. We already found our values, so we're just going to switch them. And I'm only going to write down, I can't include negative 4, negative 10. That's off of our chart. If I go negative 10, negative 4, I know I can't graph that. Then we have negative 6, negative 2, negative 2, 0, 2, 2, and 6, 4. Okay, graph those points. Oh, one other thing, you always want to make sure that you label your lines. So I'm just going to do that at the ends where my arrows are so that you know which line pertains to which equation. All right, so then we have negative 6, negative 2, and again, I'm just going to estimate. I know it's 1 off of the chart here, off of the graph. Negative 2, 0, positive 2, 2, they intersect, and positive 6, 4. Okay, draw your line as straight as you can. Again, if you have a ruler, an old ID or an ID, a piece of paper, anything with a straight edge that you can line up and use it as your guide to draw your line as straight as possible. And you can see that mine is not exactly straight. So I'm going to see if I can move this a little bit because I know that it has to intersect with my points. Or sorry, that it has to cross through that intersection because I know that my graph, both of them intersect at 2, 2, right? They both pass at that point, so you need to make sure that's happening there. Label it. This is my inverse function, and we have our graph. Okay, so what I want you to do now, and you guys know the drill, hit the pause button and do it. Find the inverse of f of x equals negative 2x plus 3. Do the composition to check and make sure that they are inverses. Make a table of values, find x and y, and graph both functions. Once you are done, come back and check your work. Okay, this is what your graph should look like, as well as your work. The inverse function of x is negative 1/2 x plus 3/2. Checking composition, you should have equal to x on both. Table of values, your values may be different than mine, and that's okay, right? As long as you have your graph. So you have two linear functions. This one is f of x here. This is the inverse function of x. And as you can see, they are complete reflections of one another over the line y equals x.